Are you drowning in a sea of Syslog data, struggling to make sense of the constant stream of messages from your network devices and legacy applications? You're not alone. While modern systems often embrace structured JSON logging, Syslog remains a vital standard, especially for networking gear and older systems. But analyzing those raw Syslog files server by server? That's a recipe for inefficiency and missed insights. This guide provides a practical solution. Setting up Fluent Bit as a centralized Syslog server that ingests logs over UDP and funnels them directly into Elasticsearch for powerful analysis. Think of it as turning your chaotic Syslog stream into actionable intelligence. Fluent Bit, think of it as a super efficient data Swiss Army knife, is a lightweight, open-source tool designed for collecting, processing, and forwarding data. It's incredibly versatile, capable of handling logs, metrics, and traces from virtually any source, transforming them, and then sending them to various destinations. You can find more about it in the official documentation. https://docs.fluentbit.io/manual. Syslog, in a nutshell, is a standardized protocol for message logging. It elegantly separates the message-generating software from the system storing and analyzing those messages. This separation simplifies management and allows for more flexible log processing. To delve deeper into the world of Syslog, check out the Wikipedia page, https://en.wikipedia.org/wiki/syslog. Syslog typically transmits messages over UDP port 514 or 5140 in non-root environments. UDP's fire and forget nature makes it exceptionally fast and lightweight, perfect for handling the high-volume logging common in routers, firewalls, and even lightweight Linux containers. But here's where it gets controversial. Raw Syslog text can be notoriously difficult to query and analyze effectively. This is where Fluent Bit shines, ingesting these unstructured messages, giving them structure, and then loading them into Elasticsearch for easy searching and analysis. Prerequisites. Before diving in, ensure you have the following: Docker and Docker Compose. These are essential for containerizing and orchestrating our demo environment. Make sure they're installed on your system. Elasticsearch. We'll be shipping our Syslog data to an Elasticsearch instance. You'll need a running instance to follow along. If you don't have one, you can easily set one up locally using this guide. https://www.elastic.co/guide/and/elasticsearch/reference/current/run-elasticsearch-locally.html. Familiarity with Fluent Bit concepts. Understanding inputs, outputs, and buffers is crucial for configuring Fluent Bit effectively. If these concepts are new to you, take a quick detour to the official documentation. https://docs.fluentbit.io/manual/concepts/data-pipeline for a foundational understanding. Our use case: a simulated environment. To demonstrate the power of Fluent Bit with Syslog, we'll create a simulated environment using Docker Compose. This environment will consist of Fluent Bit. This will be our central Syslog server, configured to listen for Syslog traffic on UDP port 5140. Alpine loggers. We'll use two separate Alpine Linux containers to mimic network devices. These containers will generate log messages every 10 seconds using the logger command and send them to our Fluent Bit container. Elasticsearch. This is where our logs will be stored, indexed, and made searchable. Let's get started. Step-by-step instructions. Create project directory. First, create a dedicated directory to house your configuration and Docker Compose files. Open your terminal and execute the following commands. Bash. Dir Fluent Bit Syslog demo. cd Fluent Bit Syslog demo. Create Fluent Bit configuration. Next, create a directory named fluentbit/config and within it, create a file named fluentbit.yaml with the following content. YAML. Service. Flush1. Log level. Info. Parsers file. Parsers.sonf. Pipeline. Inputs. Name Syslog. Mode. UDP. Listen. 0.0.0.0. Port. 5140. Outputs. Name. S. Match. Asterisk. Hashtag change these to match your Elasticsearch setup. Host 192.168.1.5. Port 9200. Index Syslog data. User Elastic. Passet RSLGLTS4. Suppress type name on. This configuration tells Fluent Bit to listen for Syslog messages on all interfaces 0.0.0.0 at UDP port 5140, and then forward those messages to your Elasticsearch instance. And this is the part most people miss. Important. Remember to update the host, HTTP_user, and HTTP_password values in the output section to match your actual Elasticsearch credentials. Failing to do so will prevent Fluent Bit from connecting to Elasticsearch. Create Docker Compose file. Now, create a file named dockercompose.yaml with the following content. YAML. Services. Fluent Bit. Image. Fluent/Fluent Bit. Latest. Container _name Fluent Bit. Ports. 6000:5140/UDP. 24224:24224. Volumes. ./fluentbit/config/fluentbit.yaml /fluentbit/etc/fluentbit.yaml. Networks. Syslog test. Restart. Unless stopped. Command. c/fluentbit/etc/fluentbit.yaml. Alpine Logger 1. Image. Alpine latest. Container name. Alpine Logger 1. Depends on. Fluent Bit. Networks. Syslog test. Command. /bin/scapk add. No cache util Linux and while true do. Logger, n Fluent Bit, p5140, t Alpine test /. This is a test message from Alpine Logger 1 at $date, /. Sleep 10. Done. Alpine Logger 2. Image. Alpine latest. Container name. Alpine Logger 2. Depends on. Fluent Bit. Networks. Syslog test. Command. /bin/scapk add. No cache util Linux and while true do. Logger n Fluent Bit, p5140 t Alpine test /. This is a test message from Alpine Logger 2 at $date /. Sleep 10. Done. Networks. Syslog test. Driver bridge. This Docker Compose file defines 3 services. Fluent Bit and 2 Alpine containers acting as log generators. The Alpine containers utilize the Logger CLI, https://wiki.alpinelinux.org/wiki/syslog, to create logs in the syslog format. The depends_on directive ensures that the loggers start after Fluent Bit, preventing potential connection issues. Run the containers. Now start the environment using Docker Compose. Bash. Docker Compose up d. Once the containers are up and running, the Alpine instances will immediately begin sending logs to Fluent Bit, which will then forward them to your Elasticsearch instance. You should see logs indicating that the containers are starting successfully. Verify logs in Elasticsearch. With everything running, it's time to confirm that the logs are making their way into Elasticsearch. Open Kibana, or your preferred Elasticsearch query tool, and search for the Syslog data index. You should see log entries originating from the Alpine loggers. Important note, we've only created indices in Elasticsearch with the pattern Syslog data star. Therefore, before you can visualize these logs in Kibana, you'll need to create a data view, https://www.elastic.co/docs/explore-analyze/find-and-organize/data-views, that matches this index pattern. This tells Kibana where to find your data. Clean up. When you're finished experimenting, you can stop and remove the containers using the following command. Bash. Docker Compose down v. The v flag ensures that any volumes created by the containers are also removed, cleaning up your system. Conclusion. From Syslog chaos to Elasticsearch clarity. Congratulations! You've successfully set up a lightweight and efficient Syslog collector using Fluent Bit. You've also simulated a real-world scenario where multiple servers send logs to a central point via UDP. Fluent Bit elegantly collected these logs and shipped them to Elasticsearch for storage and analysis, transforming raw data into actionable insights. To continue your Fluent Bit journey, explore these resources. What is Fluent Bit? https://the new stack. io/fluent